In this video, we'll cover dimensional analysis. Dimensional analysis refers to when we use mathematical operations in order to change one unit to another. For example, if we want to change inch to centimeters, or pounds to grams, or say teaspoon to liters. These are all common examples of changing one unit to another. Of course, there's not just units, but numbers that are associated with it, because 1 gram isn't equal to 1 pound. And you have to make conversion factors to do some mathematical calculations. You should see in your reference sheet a table that looks very similar to the one shown on the screen here, which is like this. And here, these are all equalities. Equalities can be changed into conversion factor form. For example, say you take 1 inch and 2.54. We can put this in the conversion factor form by putting 1 inch on top and 2.54 centimeters on the bottom. Or we can write this as 2.54 centimeters on top and 1 inch on the bottom. Either way, those are both correct conversion factor. But it will depend on which one we're going to utilize in order to do a calculation. For example, let's do a learning check related to this. Here it says you want to order a bicycle with a 25.5 inch frame, but the catalog size are only in centimeters. What size should you order? So what it's asking for really is you have 25.5 inch frame bicycle and you want to convert this into centimeters. Based on what we saw up here, we said that 1 centimeter is equal to 1 inch is equal to 2.54 centimeters. So which one am I going to use in order for me to do some type of calculation? Well, I am going to select for you for now, and next one you can try it on your own, and it's this one. The reason why I have chosen this one is because the inch goes on the bottom. And why is that an importance? Well, when you have 1 inch on the bottom, so multiply that by 1 inch on the bottom and 2.54 centimeters on the top, when the inches are in opposite of each other, so one is in the numerator, right, the 25, one is in the numerator, and you have the other inch, the 1 inch, in the denominator or the bottom. So when they're in diagonal or top in the bottom of each other, then we say we can cancel those out. And then you're left with the unit of centimeter. So let's go ahead and calculate this, and please try to get in the habits of you even calculating with the ones, even though you know you might be already math savvy, because sometimes the denominator isn't always 1. So I got my calculator. I'm going to press in 25.5 times, and then 2.54. And I see that it's 64.77. That takes care of everything that is on the top or the numerator. Now this inch is on the denominator, which is the bottom. So you're going to make a division sign, and press 1 and then enter. That should give you the same answer, which is 64.77. So the answer here is 64.77. Unfortunately, I am not done. Though this is what the calculator has spat out, we have to think about significant figures. Think of, see if you could pause this video and think how many significant figure you had to have in order for you to get the correct answer in the end. So coming back, 25.5. That problem in itself is what you're going to be looking at in order to figure out what significant figure is going to be at the end. Why not here? Well, there's a 1 inch on the bottom, so shouldn't it be one significant figure? It is a multiplication and division problem, so anything when we do multiplication and division, the 1 inch that has one sig fig is the lowest sig fig, is what you might be asking. Well, what you also need to know is in the significant rule is that it comes from an equality. When it comes from an equality type of equation, it is infinitely many, a lot of significant figure beyond this one. So we take in the 25.5, which has 3 sig figs. So my final value should be 64.8 centimeters. And that's my final answer with the correct sig figs. So let's do a next one. You try the next one and see if you could come back. So coming back, it says student has entered 10.0 kilometers run. How long is the run in meters? So this is a typical meter and kilometer equation. It is not on that table right above us, but it is in your reference sheet, and there is multiple of meters to kilometers to millimeters to megameters, telemeters. There's a bunch of different meters in there. So look in that reference sheet and see if you can find the relationship between a kilometer and a meter. And you should find that 10 to the third meter is equal to 1 kilometer. We know that the problem itself is 10.0 kilometer, and then we want to do some calculation so that in the end we're just left with meters. So to cancel out the kilometers, we have two fraction form that we can think of. Either 1 kilometer goes on top or the meter goes on top. Based on what I see over here, I'm going to be utilizing the second one. And that's because I want to cancel out the kilometers. 1 kilometer and 10 to the third meter. So if I were to punch this into the calculator, I would do as follows. 10.0 times 10 to the is the little hat sign on the cosine above it, to the third power, and then hit enter. You should get 10,000. Then divided by the denominator, which is 1 kilogram, just 1, and so this again, 10,000. So kilometers cancel out, and we're left with 1,000. Okay. We are not done. Remember, we have to put this in the correct sig figs. The correct sig figs here is 3. So how do we make the 10,000 into 3 sig figs? When you have an issue that comes up like this, then you're going to introduce the scientific notation. All digits, all units have, all numbers have an imaginary decimal at the end, whether there's or not, whether it's needed or not. And we're going to jump 1, 2, 3, and 4. So this is 1.00 times 10 to the 4th meters. So 10 kilometers is equal to 1 times 10 to the 4th, 1.00 times 10 to the 4th meters, right? Let's take it up a notch. A Japanese car is advertise having a gas mileage of 1501 kilometers per liter. Convert this rating to miles per milliliter. Whenever you see per, it's 15.01 kilometers per liter. That means all over 1 liter. You want to do some type of all these problems so that in the end, you're with miles instead of kilometers, and then milliliters instead of liters. So you have to go through a little bit of math, and you take one step at a time. Do you see a relationship between kilometer and a mile? Let's see, let me go back. Yeah, it's this one right here, right? The kilometers to mile, that's relationship is there. So the conversion factor form we see as follows. We can say that 1 kilometers is equal to 0.213762. And the other one, miles, all right, 0.62137 miles all over kilometers. And which one are we going to use? Hopefully you were able to say we're going to use this one because we can get the kilometers to cancel out. So we're going to go ahead and put that there. So multiply by 0.262137 miles. So we miles per kilometer. We know that kilometers cancel out and we have miles. The liters. Every 1 liter is equal to 10 to the third milliliter. Therefore, we can use a fraction forms forming 1 liter on top and 10 to the third milliliters on the bottom. So liters cancel out and you're left with just milliliter. Drop my calculator. All right. So in my calculator, I'm going to type 15.01 times 0.6217 times it by 1 liter. And then divide that by, okay, open up a parentheses, which is right under cosine, right here. Then type in 1 times 1 times 1. I'm doing all the denominator, the ones that are on the bottom, and then to the third power. Then it should spit out some big number, 0.00932676, so on and so forth, right? But we want it in 4 sig figs because that's the problem that it's asking for. So it's going to be 0.9 to 9327.